Okay, 1.2 is linear equations and rational equations. So in this lesson, we're going to solve linear equations in one variable, and we're going to solve linear equations that contain fractions. A linear equation in one variable x is an equation that can be written in the form of ax plus b equals 0, where a and b are real numbers, but a is not equal to 0. All right, so to generate equivalent equations, it says an equation can be transformed into an equivalent equation by one or more of the following operations. Simplify an expression by removing grouping symbols and combine like terms. So get rid of the parentheses and then combine like terms is what it's saying. Then you're going to add or subtract the same real number variable expression on both sides of the equation. So you're going to move what's being added or subtracted to that x value. Then you're going to multiply or divide by the same non-zero quantity on both sides of the equation. And then we can interchange the two sides of the equation if needed. So if you like x being on the left but your x is on the right, you can just switch it around. To solve a linear equation, it says simplify the algebraic expression on each side by removing grouping symbols and combining like terms. Sounds familiar. Then we're going to collect all the variable terms on one side and all the numbers or constant terms on the other. So I always do variables on the left and then the non-variables on the right. But it doesn't really matter which side you put it on, as long as one side has all your variables and the other side has no variables. Then you're going to isolate the variable and solve. Check the proposed solution in the original equation to make sure your answer is correct. All right, so in example 1, it says to solve and check this linear equation. So we're going to solve and check that 4x plus 5 equals 29. So first, let's solve that. And so I can see that my x's are all on the left, so I need all my non-x's on the right. So we're going to subtract this 5 to move it over. Remember what you do to one side, you do to the other. When you're on this line here, they should always be exactly the same thing. So like if I had to accidentally put a plus 5 here, negative 5 is not equal to positive 5, so I know I made a mistake. All right, so that's going to cancel, and it leaves us the 4x equals 29 minus 5 is 24. Divide by the 4. 4's cancel because it's a 1. 1x is the same thing as x equals, and 24 divided by 4 is 6. Now, before I can say that that's my solution, I need to check it. And so for the check, we're plugging into 4x plus 5 equals 29. And we're going to check when x equals 6. So we got 4x plus 5 equals 29. So I'm going to set up my skeleton here, and I'm going to plug that 6 in to where x was. Now, when you do a check, guys, you don't move anything from the left to the right. You do one side, you do the other side, and you compare your answer at the bottom. So I'm going to work the left side first. So I'm only looking at this. I don't care about that 29 over there. So we know with PEMDAS, the first thing we're going to do here is we're going to multiply. So 4 times 6 is 24. Bring down your plus 5. 24 plus 5 is 29. Now look at the other side. There's nothing to solve. It's just 29, so we can just bring that down. And then ask yourself, is 29 equal to 29? Yes, they're the same number. Therefore, x equals 6 is our solution. All right, but what if they have fractions? We don't really like fractions. So what we want to do is we want to find what we would use as our least common denominator if we were going to actually add or subtract these together. All right, so in order to do that, let's factor down our denominators to their prime numbers. So 4 is 2 times 2. 14 is 2 times 7, and well, 7's already prime, so it's going to just be a 7. Now for that least common denominator, remember when we were doing the rational functions before, we looked at this. So this first one, I need 2 2's. Well, I don't have anything written down right now, so I'm going to put 2 2's up there. For the second one, we just check now. We're only going to include anything that we don't already have up there. So I need a 2. Do I have a 2 already written up there in that least common denominator? I do, so don't write it again. I need a 7. Do I have a 7 written up there already? I don't, so come up here and put times 7. Then for the third fraction, I need a 7. Is there a 7 written up there already? There is, so don't write it again. So this least common denominator is what we're going to multiply everything by. So every term here is going to get multiplied by 2, 2, and 7. So multiply this by 2, 2, and 7. This one's going to be by 2, 2, and 7. And this one here is by 2, 2, and 7. All right, so for the first fraction, we want to get rid of these two 2's on bottom because that'll get rid of the 4. So I'm going to cancel out the two 2's, and I'm left with the 7 times what's inside. So we get 7 times x minus 3. There's an equal sign. Now for the second fraction, I had a 14, which was a 2 and a 7. So I need to get rid of the 2, a 2 and a 7. So I'm left with 2 on the outside times a 5 on the inside. And then there's a minus sign. Then the last fraction, I needed to get rid of the 7 on the outside. So I have 2 times 2 left on the outside and x plus 5 on the inside. So the 2 times 2 on the outside times the x plus 5 on the inside. And because this has an equal sign in it, we don't have to worry about the denominators because technically both sides should be over that 2 times 2 times 7. But if our denominators are equal, then that means our numerators have to be equal as well. So we're just going to solve this. Now we can only do this if there's an equal sign in it, okay? So when I go to solve this, on the left I can distribute. So I get 7x minus 21 equals, on the right side here, I can multiply those. 2 times 5 is 10. And then here, I got minus 2 times 2, which is 4. And then I'm just going to bring down my times x plus 5. I can't do anything else on the left, so just bring it down for now. On the right-hand side, I can't do anything with that 10, but I can now take that negative 4 and distribute it. Don't forget to take the negative with the number. A sign always goes with the number behind it. So negative 4 times x is negative 4x. And negative 4 times that positive 5 is negative 20. Can't do anything else on the left still. But on the right side, I can combine like terms. So 10 minus 20 is negative 10, and I still have my minus 4x. Now I can't do anything on the left. I can't do anything on the right. So it's time to start moving them from side to side. So pick whichever side you want your x's to be on. And I'm going to choose the left side. So I'm going to add this 4x over. And so I got 11x minus 21 equals the negative 10, and then that 4x canceled. Now I'm going to move my non-x's to the right, so I'm going to add the 21. Remember, we always do the opposite. And since it was a negative 21, we're going to add it. And so we get 11x equals 11. Then this is 11 times x, so to get rid of that 11, we do the opposite, which is divide. And so 11 divided by 11 cancels, so we get x equals. Even though they cancel on this side, we still know 11 divided by 11 is 1. But I need to make sure I check this. So we're going to check it. And we're going to check when x equals 1. So I'm going to set up my problem. It was x minus 3 over 4. And so I'm going to plug in that 1. Equals, this is just 5 over 14 minus x plus 5 over 7, and plug in the 1 for the x. And then before you even try to put this in your calculator, guys, y'all mess up a lot of times when you have like multiple things in the numerator or the denominator. So I'm just going to simplify these fractions a little bit. So for the first one, we've got 1 minus 3, which is negative 2 over 4 equals, over here we got 5 over 14 minus 1 plus 5 is 6 over 7. Well, now we can work this out. Remember now when you're, I forgot to mention, but when we are checking, excuse me, sorry I lost my train of thought. All right, so when we're checking our problem, then we need to work one side and then the other side. So I really shouldn't have worked both there. But the negative 2 over 4 I can reduce. If I put that in my calculator, it tells me it's a negative 0.5. And so then on this other side, now that I've just got two fractions being subtracted, I'll put it in my calculator. 5 divided by 14 minus 6 divided by 7. You hit enter and it says negative 0.5. Because that's true, that means that x equals 1 is our solution. All right, so let's try another one here. So again, I want to get rid of the denominators. I don't want to have any fractions. So I'm going to break down the 8. It's 4 times 2, but 4 is not prime. So it's 2 times 2 times the 2. 3 is prime, but 12 is what? 6 times 2? Or you could say 3 times 4. It doesn't matter. We get the same answer in the end. 6 is 3 times 2, and bring down that other 2. All right, so for my least common denominator, for that first fraction, you're always going to just write these down. Whatever's in the first one, you're going to put because there's nothing there. I need 3 2's. So 2 times 2 times 2. For the second fraction there, I need a 3. Do I already have one? I do not, so put a 3 up here. For the third fraction, I need a 3. Do I have a 3 up there? I do. And I also need 2 2's. Do I have 2 2's up there? I do. Now, if I'd only had 1 2 up there, I would have added a second one to make sure this denominator was taken care of. All right, so we know our least common denominator is 2 times 2 times 2 times 3, and so that's what we're going to multiply every one of these terms by. So 2 times 2 times 2 times 3. 2 times 2 times 2 times 3, and 2 times 2 times 2 times 3. All right, so for the first fraction, we wanted to get rid of those 3 2's. So we're going to mark out 3 of the 2's, and so we're left with a 3 times a 3x. So we have 3 times 3x, and it's a plus sign there. The second one, I just wanted to get rid of the 3, so I have 2 times 2 times 2 times the 1 inside. So 2 times 2 times 2 times the 1 inside, and then it's an equal sign. And then the third fraction, I need to get rid of a 3 and 2 2's. So 3 and 2 2's, so I'm left with 2 on the outside times a 7 on the inside. Now let's just simplify the left side of this. So we got 3 times 3x is 9x plus 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8 times 1 equals, on the other side here, we just have 14. Now, I know some of y'all are like, well, I could do 8 times 1 at the same time, and you're welcome to. That's no big deal. So I can't do anything with a 9x, so I'm going to bring it down. Positive 8 times 1 is positive 8 equals 14. Now we got to get x by itself, so I need to get rid of that 8. It doesn't have an x, so it needs to go to the other side. It's a positive 8, so we're going to subtract it. And so we have 9x left on the left equals 14 minus 8 is 6 divided by 9 to get x by itself. And we get x equals 6 over 9. I'm going to put it in my calculator. It gives me an ugly decimal. Don't give it to me as a decimal. Give it to me as a reduced fraction then. So hit math enter. Or we could have said, well, 6 and 9 are both divisible by 3. Either way, we end up with 2/3. And the directions did say to check it. So if it says to check it, I will be looking for that. So for our check, we're plugging in that x equals 2/3. So we have 3 over 8 times x, which we're going to put in 2/3, plus 1/3 equals 7/12. Now remember with fractions, we talked about this in a previous unit. When we multiply straight across. And so right here where we're multiplying, we can multiply straight across and reduce it, or we can just say, oh yeah, remember if we have something on the top and the bottom and it's being multiplied, it can cancel. So I have a 3 on top and bottom, so I can cancel them. So I get 2 over 8 plus 1 over 3. I'm just going to work this one side at first. So let me draw my line. And then now that I've just got 2 fractions being added, I could put that in my calculator. So 2 divided by 8 plus 1 divided by 3 is going to give you a decimal, but we see on the other side all we have is 7/12. So hit math enter. And so you end up with 7 over 12, which is what the other side is already. We didn't have any work to do. That worked, which means 2/3 is our solution. And let's try another one. So same steps. We're going to find that least common denominator. Let's see, 3 is prime, 2 is prime, and 1's not a fraction, so we can put it over 1, which would be prime as well. So I'm actually going to erase these. I don't need them because they were already prime. So I know for my least common denominator, I need a 3. I know I've got to have a 2. I don't have one already, so I'm going to put 1. And then whether or not you do the last one is up to you. But if you do, some people like 2, so you need a 1. I don't have a 1 there, so I'm going to put it. All right, so we're going to multiply by 3 times 2 times 1. So each fraction, or each term, including just that 1, is going to get multiplied by 3 times 2 times 1. All right, so for this first one, my 3 is going to cancel, and I'm left with 2 times 1 times the 4x plus 7. So 2 times 1 times the 4x plus 7. See, there's a minus sign after that. The next fraction, the 2 is going to cancel, so I'm left with 3 times 1 on the outside times the x plus 3 inside. And there's an equal sign. And then the 1's going to cancel, so I'm left with 3 times 2 on the outside times the 1 on the inside. I'm going to have to squeeze that in here. All right, now we're ready to simplify each side. I'm going to draw this one crooked on purpose because I'm going to have to, well, nah, it'll be fine. All right, so 2 times 1 is 2 times the 4x plus 7 minus 3 times 1 is 3 times the x plus 3. 3 times 2 is 6 times the 1. Now on the left side here, we're going to distribute this 2 to its parentheses. So 2 times 4x is 8x. And 2 times 7 is a positive 14. Then we're going to distribute that negative 3 to its parentheses. So negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. Equals, and over here 6 times 1 is 6. On the left, I'm going to go ahead and combine like terms. We've got 8x minus 3x, which is 5x. We have 14 minus 9, which is positive 5. And we got equals 6. Now we're trying to get x by itself, so I'm going to subtract the 5. And so we get 5x equals 1. Divide by the 5. And so we get x equals, you can do it as 1/5, or when you, excuse me, when you plug that in your calculator, it gives you a nice, neat decimal, 0.2. So you're welcome to use either one of those. All right, so when we go to check this, because it says to check it, we're going to plug in x equals, and I'm going to go ahead and use the 0.2. So we got 4x plus 7 over 3, and so I'm plugging that 0.2, minus x plus 3 over 2, I'm going to plug in the 0.2, equals 1. Now remember, we work each side individually. So let's work on this, the left side. So we got 4 times 0.2, which is 0.8, plus 7 over 3, minus 0.2 plus 3 is 3.2 over 2. I'm going to add this first one, 0.8 plus 7 is 7.8 over 3 minus 3.2 over 2. Now, I know we're not supposed to have decimals and fractions, but we're going to put this in our calculator probably anyways. So now that we've just got a fraction minus a fraction, put it in, 7.8 divided by 3 minus 3.2 divided by 2, and it comes out to be 1. Well, the other side, I don't have anything to work, so I'm going to bring it down and then check, is that true? Is 1 equal to 1? It is, therefore, either one of these we could say would be our solution. They're the same number, so it's whichever way you want to write it. Now, I wrote this one as a 0.2, where on the previous one, when it was 2/3, I didn't give its decimal. 2/3 is 0.66666666666, and it keeps going forever. Okay, so that one we want to change to a fraction. This one, when I typed in 1 divided by 5, it was 0.2. Nothing after it. It's a nice, neat decimal. Doesn't keep going, so you can use it.